Hello, welcome back. Welcome back. I'm John, an old YouTuber. Let's record with my 10 years old Canon. My JVC camcorder is out of power. Let's read the Pentium 4 PDF. I buy these 3 old gamer computers. This is an old Acer Aspire Pentium, I think it's a Pentium D. It's a Pentium dual core Pentium D. This is old Acer Aspire Intel Core i5 650 first generation. This is old Acer Aspire Intel Core i3 fourth generation there. Yes, but I cannot really read it from there. Yes, Intel Core. Yes, but the Pentium 3 is ready. Put it public. And I start to get tired. But I'm always tired. Good. Pentium 3 is public on my YouTube channel. No, I'm tired because I'm not sleeping enough in the night, and it's always very hot in my apartment. Now it's 28. It was 29 not long time ago, but I'm freezing a little bit and sneezing. And it's been like 30 degrees hot or more, like in 4 or 5 weeks, the whole August. Yes, let's try adjust the screen. But this is my 10 years old Canon. But the sound, it can record text, and the sound is working. So I need to try get, but Pentium 4 was out in November year 2000. So that's more than 20 years ago. But this can run a Windows 7. Pentium 4 can run Windows 7. Because it's got this SSE2 instructions, this one. But how well it runs Windows 7, I don't know.
Pentium 4. Pentium 4 Pentium 4-2,4.
Yes, I was watching Netflix. I forgot to put the sound back on. 54. Let's try again.
Pentium 4. Pentium 4 Pentium 4-2,4 GHz.jpg. Picture of Pentium 4 General Information launched November 20, 2000 discontinued August 8, 2008 Performance Max. CPU clock rate 1.3 GHz to 3.8 GHz FSB speeds 400 mount /s to 1066 mount /s architecture and classification microarchitecture net burst instruction set x86, i386, x86-64, only some chips, MMX, SSE SSE2, SSE3, since Prescott. Physical specifications: transistors 42M 180nm 55M 130nm 169M 130nm P4E 125M 90nm 188M 65nm Socket S Socket 423 Socket 478 LGA 775 Pentium 4, 1, 2 is a series of single-core CPUs for desktops, laptops and entry-level servers manufactured by Intel. The processors were shipped from the 20th of November, 2000 until August 8, 2008. 3, 4. The production of NetBurst processors was active from 2000 until the 21st of May, 2010. 5, 4. All Pentium 4 CPUs are based on the NetBurst microarchitecture. The Pentium 4 Willamette 180nm introduced SSE2, while the Prescott 90nm introduced SSE3. Later versions introduce EDIPA threading technology, HTT. The first Pentium 4 branded processor to implement 64-bit was the Prescott 90nm, February 2004, but this feature was not enabled. Intel subsequently began selling 64-bit Pentium 4s using the E0 revision of the Prescotts, being sold on the OEM market as the Pentium 4 Model F. The E0 revision also adds Execute Disable, XD, Intel's name for the NX bit, to Intel 64. Intel's official launch of Intel 64, under the name M64T at that time, in mainstream desktop processors was the N0 stepping Prescott 2M. Intel also marketed a version of their low-end Celeron processors based on the NetBurst microarchitecture, often referred to as Celeron 4, and a high-end derivative, Xeon, intended for multi-socket servers and workstations. In 2005, the Pentium 4 was complemented by the dual-core brands Pentium D and Pentium Extreme Edition. Contents: microarchitecture testing and validation. Processor cores: Willamette, Northwood Pentium 4M, Mobile Pentium 4, Northwood Extreme Edition, Prescott 2M Extreme Edition, Cedar Mill. Successor. See also: history. Predecessor Pentium 3, successor Pentium M, mobile. Pentium D, desktop. Notes and references. External links. Microarchitecture. In benchmark evaluations, the advantages of the NetBurst microarchitecture were unclear. With carefully optimized application code, the first Pentium 4s outperformed Intel's fastest Pentium 3, clocked at 1.13 GHz at the time, as expected. But in legacy applications with many branching or x87 floating point instructions, the Pentium 4 would merely match or run slower than its predecessor. Its main downfall was a shared unidirectional bus. The NetBurst microarchitecture consumed more power and emitted more heat than any previous Intel or AMD microarchitectures. As a result, the Pentium 4s introduction was met with mixed reviews. Developers disliked the Pentium 4 as it posed a new set of code optimization rules. For example, in mathematical applications, AMD's lower clocked Athlon, the fastest clocked model, was clocked at 1.2 GHz at the time, easily outperformed the Pentium 4, which would only catch up if software was recompiled with SSE2 support. Tom Yeager of InfoOld magazine called it the fastest CPU, for programs that fit entirely in cache. Computer-savvy buyers avoided Pentium 4 PCs due to their price premium, questionable benefit, and initial restriction to Rambus RAM. 6, 7, 8. In terms of product marketing, the Pentium 4's singular emphasis on clock frequency, above all else, made it a marketer's dream. 9. The result of this was that the netburst microarchitecture was often referred to as a Marchitecture 10 by various computing websites and publications during the life of the Pentium 4. It was also called netbust 1110, a term popular with reviewers who reflected negatively upon the processor's performance. The two classical metrics of CPU performance are IPC, instructions per cycle, and clock speed. While IPC is difficult to quantify due to dependence on the benchmark application's instruction mix, clock speed is a simple measurement yielding a single absolute number. Unsophisticated buyers would simply consider the processor with the highest clock speed to be the best product, and the Pentium 4 had the fastest clock speed. Because AMD's processors had slower clock speeds, it countered Intel's marketing advantage with Megahertz Myth campaign. AMD product marketing used a PR rating system, which assigned a merit value based on relative performance to a baseline machine. Pentium 4 will emit 1.5 GHz on socket 423. At the launch of the Pentium 4, Intel stated that netburst-based processors were expected to scale to 10 GHz, 12, after several fabrication process generations. However, the clock speed of processors using the netburst microarchitecture reached a maximum of 3.8 GHz. Intel had not anticipated a rapid upward scaling of transistor power leakage that began to occur as the die reached the 90 nm lithography and smaller. This new power leakage phenomenon, along with the standard thermal output, created cooling and clock scaling problems as clock speeds increased. Reacting to these unexpected obstacles, Intel attempted several core redesigns, Prescott most notably, and explored new manufacturing technologies, such as using multiple cores, increasing FSB speeds, increasing the cache size, and using a longer instruction pipeline along with higher clock speeds. Pentium 4 Prescott 2.40 GHz on socket 478. Pentium 4 height Prescott 3.0 GHz on socket 478. The code cache was replaced by a trace cache which contained decoded microoperations rather than instructions, with advantage of eliminating instruction decoding bottleneck so that the design can use ISC technology. 1348. This came with a disadvantage of less compact cache taking up more chip space and consuming power. 1348. These solutions failed, and from 2003 to 2005, Intel shifted development away from netburst to focus on the cooler running Pentium M microarchitecture. On the 5th of January, 2006, Intel launched its core processors, which put greater emphasis on energy efficiency and performance per clock cycle. The final netburst-derived products were released in 2007, with all subsequent product families switching exclusively to the core microarchitecture. Testing and validation. According to Bob Bentley, presenting on behalf of Intel at the 38th Annual Design Automation Conference, the microarchitecture of Pentium 4 processor is significantly more complex than any previous IA32 microprocessor, so the challenge of validating the logical correctness of the design in a timely fashion was indeed a daunting one. He hired a team of 60 recent graduates to help with testing and validation. 14. Processor cores. Intel Pentium 4 processor family. Desktop laptop codename Ignode. Release date codename Ignode. Release date Willamette Northwood Prescott 180 nm 130 nm 90 nm November 2000 Jan 2002 March 2004 Northwood 130 nm June 2003 Northwood Pentium 4 M 130 nm Ma 2002 Hyper-threading. Height Northwood Prescott 2MC DeMille 130 nm 90 nm 90 nm 65 nm November 2002 February 2004 February 2005 Jan 2006 Northwood Prescott 130 nm 90 nm Seep 2003 June 2004 Gallatin XE Prescott 2M XE 130 nm 90 nm Seep 2003 February 2005 List of Intel Pentium 4 processors. Pentium 4 processors have an integrated heat spreader, IHS, that prevents the die from accidentally being damaged when mounting and unmounting cooling solutions. Prior to the IHS, a CPU shim was sometimes used by people worried about damaging the core. Overclockers sometimes removed the IHS from socket 423 and socket 478 chips to allow for more direct heat transfer. On socket 478 Prescott processors and processors using the socket LGA 775, socket T, interface, the IHS is directly soldered to the die or dies, making it difficult to remove. Willamette Pentium 4 Willamette 1.5 GHz boxed Pentium 4 Willamette 1.5 Gs 4 socket 423 Pentium 4 1.5 GHz, Willamette, with Intel 850 chipset Willamette, the project code name for the first NetBurst microarchitecture implementation, experienced long delays in the completion of its design process. The project was started in 1998 when Intel saw the Pentium 2 as their permanent line. At that time the Willamette core was expected to operate at frequencies up to about 1 GHz. However, the Pentium 3 was released while Willamette was still being finished. Due to the radical differences between the 6P and NetBurst microarchitectures, Intel could not market Willamette as a Pentium 3, so it was marketed as the Pentium 4. On the 20th of November, 2000, Intel released the Willamette-based Pentium 4 clocked at 1.4 and 1.5 GHz. Most industry experts regarded initial release as a stopgap product, introduced before it was truly ready. According to these experts, the Pentium 4 was released because the competing Thunderbird-based AMD Athlon was outperforming the aging Pentium 3, and further improvements to the Pentium 3 were not yet possible. This Pentium 4 was produced using a 180 nm process and initially used socket 423, also called socket W, for Willamette, with later revisions moving to socket 478, socket N, for Northwood. These variants were identified by the Intel product codes 80528 and 80531 respectively. On the test bench, the Willamette was somewhat disappointing to analysts in that not only was it unable to outperform the Athlon and the highest clocked Pentium 3s in all testing situations, but it was not superior to the budget segment's AMD Duran. 15, Alt-Half introduced at prices of $644, 1.4 GHz, and $819, 1.5 GHz, for 1,000 quantities to OEM PC manufacturers. Prices for models fourth consumer market varied by retailer. It sold at a modest but respectable rate, handicapped somewhat by the requirement for relatively fast yet expensive rambus dynamic RAM, a DRAM. The Pentium 3 remained Intel's top-selling processor line, with Athlon also selling slightly better than the Pentium 4. While Intel bundled two DRAM modules with each boxed Pentium 4, it did not facilitate Pentium 4 sales and was not considered a true solution by many. In January 2001, a still slower 1.3 GHz model was added to the range, but over the next 12 months Intel gradually started reducing AMD's leadership in performance. In April 2001, a 1.7 GHz Pentium 4 was launched, the first model to provide performance clearly superior to the old Pentium 3. July saw 1.6 and 1.8 GHz models, and in August 2001, Intel released 1.9 and 2 GHz Pentium 4S. In the same month, they last the 845 chipset that supported much cheaper PC133's DRAM instead of a DRAM. 16. The fact that DRAM was so much cheaper caused the Pentium 4S sales to grow considerably. 16. The new chipset allowed the Pentium 4 to quickly replace the Pentium 3, becoming the top-selling mainstream processor. Pentium 4 Willamette, socket 478, top and bottom sides showing contact pins and the market. The Willamette code name I derived from the Willamette Valley region of Oregon, where a large number of Intel's manufacturing facilities are relocated. Northwood. A Northwood Core Pentium 4 processor. At left is the die, black square in the center, and at right the heat spreader die shot of a Northwood Pentium 4. In January 2002, Intel released Pentium 4S with a new core code named Northwood at speeds of 1.6 GHz, 1.8 GHz, 2 GHz and 2.2 GHz. 17, 18, Northwood, product code 80532. Combined an increase in the L2 cache size from 256 kilobytes to 512 kilobytes, increasing the transistor count from 42 million to 55 million, with a transition to a new 113 fabrication process. 18, making the processor out of smaller transistors means that it can run at higher clock speeds and produce less heat. In the same month, boards utilizing the 845 chipset were released with enabled support for DDR's DRAM, which provided double the bandwidth of PC133's DRAM, and alleviated the associated high costs of using RAM-bus DRAM for maximal performance with Pentium 4. A 2.4 GHz Pentium 4 was released on the 2nd of April, 2002, and the bus speed increased from 400 mount/s to 533 mount/s, 133 MHz physical clock, for the 2.26 GHz, 2.4 GHz, and 2.53 GHz models in May, 2.66 GHz and 2.8 GHz models in August, and 3.06 GHz model in November. With Northwood, the Pentium 4 came of age. The battle for performance leadership remained competitive, as AMD introduced faster versions of the Athlon XP, but most observers agreed that the fastest clocked Northwood-based Pentium 4 was usually ahead of its rival. This was particularly so in mid-2002 when AMD's changeover to its 130nm production process did not help the initial thoroughbred revision Athlon XP CPU's tar clock high enough to overcome the advantages of Northwood in the 2.4 to 2.8 GHz range. 19. The 3.06 GHz Pentium 4 enabled hyper-threading technology that was first supported in Foster-based Xeons. This began the convention of virtual processors, or virtual cores, under x86 by enabling multiple threads to be run at the same time on the same physical processor. By shuffling two, ideally differing, program instructions to simultaneously execute through a single physical processor core. The goal is to best utilize processor resources that would have otherwise been used from the traditional approach of having these single instructions wait for each other to execute singularly through the core. This initial 3.06 GHz 533 FSB Pentium 4 hyper-threading enabled processor was known as Pentium 4 Height and was introduced to mass market by Gateway in November 2002. On the 14th of April, 2003, Intel officially launched the new Pentium 4 Height processor. This processor used an 800 mount/s FSB, 200 MHz physical clock, was clocked at 3 GHz, and had hyper-threading technology. 20. This was meant to help the Pentium 4 better compete with AMD's Optron line of processors. The server-oriented Optron initially did not share a common socket with AMD's desktop processor line, Socket A. Because of this, motherboard manufacturers did not initially build motherboards with AGP for Optrons, as AGP was the primary graphics expansion port for desktop use. This oversight prevented the Optron from encroaching from the server market and threatening the Pentium 4 desktop market. Meanwhile, with the launch of the Athlon XP 3200 Plus in AMD's desktop line, AMD increased the Athlon XP's FSB speed from 333 mount/s to 400 mount/s, but it was not enough to hold off the new 3X Pentium 4 height. 21. The Pentium 4 heights increased to a 200 MHz quad-pumped bus. 200x4 equals 800 MHz effective. Great Lie helped to satisfy the bandwidth requirements the NetBurst architecture desired for reaching optimal performance.